So what we're going to do is, since I'm not gloved, Reed is going to pour about 50 mils, 75 mils of this RAS sample in, RAS sample, returned activated sludge, and we actually get this from the wastewater treatment plant. There's like a little, probably like a little valve that we can pull it off, right?
Secondary treatment is a biological process where we will be using microorganisms to help clean our wastewater. The microorganisms are in there, but what do they need to be happy and help clean our wastewater?
What would make you very grumpy if I took it away from you forever? Phone. It also begins with the th sound, food. Is there sugar in this water? Yes. Is there ammonia in this water? Yes. Can the bacteria now do their job? No. What have I not added? I have not added oxygen. The little bubbler is now on, and if you can look behind, can you guys see the bubbles coming off of the bubbler? Yeah. Yes.
Now the microorganisms are happy. So we're going to let them work, removing nutrients and other organic matter, such as ammonia, sugar, protein, carbohydrates, the things we added in the very beginning while we made our wastewater. These microorganisms use the food for themselves, removing it from the wastewater for us, making it a win-win. For this lab, we're going to focus on the importance of removing ammonia and other nitrogen compounds from our wastewater. At Nome & Cole, secondary treatment consists of two processes, our ASTs, or activated sludge tanks, and secondary sedimentation. The ASTs are where we add these microorganisms, and the wastewater travels between two zones, those that we add oxygen to and those that we don't. This allows microorganisms to break down the ammonia into nitrogen gas through the nitrogen cycle. After going through multiple oxygen, no oxygen zones, the wastewater travels to the secondary clarifiers. This is where we settle out microorganisms during our secondary sedimentation. What happens to the microorganisms that we settle out? Well, in primary treatment, we send all of that sludge and scum that we removed to the on-site incinerator. Here, we love these guys, and we need them. So we're going to send some of them back to the ASTs to clean our wastewater again. It's a feast for them, cleaner water for us.
Microorganisms are now removed from the process to represent what happens at the treatment plant.
Let's go ahead and take a look at what our tank looks like now. So it's been put back into the sedimentation tank.
At the wastewater treatment plant, there is a big difference between the water coming into the clarifiers and the water leaving the clarifiers. At this point, you can see the water is starting to look cleaner, but we're not done yet. Before moving to advanced treatment, let's pause. Take a little time to look at the microorganisms we might commonly see in our wastewater.
At the end of secondary treatment, our wastewater is definitely starting to look cleaner. This is the second of 4 treatment processes. Remember, secondary treatment is a biological process that uses microorganisms and oxygen to break down nutrients and organic matter in wastewater. Did you know Nome & Cole was built in 1970 with only primary and secondary treatment? Today, it's an advanced treatment plant with 4 treatment processes, but there are still some places in the United States that only treat wastewater through the biological process of secondary treatment, a critical step in removing various pollutants from our wastewater. So what if the microorganism population is jeopardized and it can't remove these pollutants as expected? This can happen with the improper disposal of items such as household hazardous waste down our toilets and sinks.
You may be wondering, what is household hazardous waste? Household hazardous waste refers to the leftover contents of consumer products that contain materials that are ignitable, corrosive, toxic, or reactive, according to the EPA. These type of waste should never be placed in the regular trash. Common types of household hazardous waste include insecticides, pesticides, herbicides, fungicides, mothballs, flammable or combustible materials, solvents, including paint thinner, mineral spirits, gasoline, and varnish, household cleaners, that contain sodium hydroxide or bleach, ammonia, acids such as muriatic or hydrochloric, aerosol spray cans, pool chemicals, oxidizers, cylinders such as propane, and fire extinguishers, and mercury-containing items such as thermometers, thermostats, or switches, just to name a few.